Okay, now the next example. Now a steel bar A, B, C, D, 4 meter long. So that's part AB, section AB is 1 meter, section BC is 2 meter, and section CD is 1 meter. Okay, 4 meter long is subjected to forces. These are the forces, yeah. Okay, as shown. Find the elongation of the bar. Take the Young's modulus for the steel as 200 gigapascal. So from here you can see, okay, the first thing you have to check is whether the whole section is in equilibrium or not. So you have to check total left hand forces is 10 here, left. This is left also, 30. Total left is 30, okay. Then right, this is right, 5, right, 25. Total right is also 30. So that means the bar is in equilibrium, so it's safe to solve. So the next thing is apply principle of superposition. Split this into, now you can see AB, BC, and CD like this. So I use the normal method now, splitting it up into 3 parts as according to what you have shown. Just now, the previous example, you can do so also. You can split it up into the exact parts, okay? But then make sure when you consider the forces, make sure you consider it correctly. So I can split this into 3 parts. Part 1, okay? So if this is 20, I just take 20, whatever I have here. Just now I am playing a bit, I'm doing it a bit different to show you that, okay, it can be done in multiple ways, okay? So if, let's say, for example, you are still not familiar with it, you can always stick with this first value here as 20. So this is 20 and it's pointing towards the left. Then this end here, you must consider 20 also, but it's pointing towards the right. Okay, for the equilibrium of this part 1 here with section AB. And then you can consider the next part that is here. Okay, but then as you compare this section B and this section B here is only 5, but I have 20 here. So that means I must remove 15. 15. I must remove 15 from here to compare to the 5 here. So 20 minus 15, I will get back my 5 here, section B. Okay, so therefore, you have to, at this end here, at this section B here of the second part, you must consider the arrow pointing towards the right with a value of 15. Why towards the right? Because it is towards the left, so that is why here you have to consider towards the right. Then only you can deduct, because different direction means minus, same direction means plus. Okay, so you have this different direction. Why I put different direction? Because I'm going to minus off 15 from here. Why should I minus 15 from here? Because I want to get back this 5 here. Okay, so 15. So for the equilibrium of this part, once you have got this is pointing towards left, so I must have an arrow pointing towards right. Okay, and the magnitude should be 15. Okay, then the next part, that is the part 3. Okay, so that should be the section CD. Okay, so initially when you look at this is 10, but I have 15 here, and then 15 is pointing towards the right and 10 is pointing towards the left. Okay, so how much I must consider here to have the force of 10 kilonewton in this direction? I must consider how much in order to have a force in this direction, whereas this is 15. So how to get a 10? So I must consider here 25 in this direction. So if this is 25 in this direction, okay, together with this, which has 15 in this direction, so that means I minus 25 minus 15, so I get 10. Okay, so once I got this, here I must consider a force pointing towards the right, which is also 25. Because for the equilibrium of part 3, that is section CD. Okay, once you have got this, okay, you check this is 25, correct. This is 20, correct. Okay, so 3 parts. So you use this. This is a total deformation. So area, is it the same, the cross-sectional area? Okay, so 30 mm, they give you diameter 30 mm, then of course you have to find out the area, the cross-sectional area here this time, because they are not given you in terms of area, they're given you in terms of diameter here this time. So you have to of course find out the area. Okay, the area, and the area. I'm using pi r squared. Pi d square over 4, using pi d square over 4, pi d square over 4, pi d square over 4. You can also actually extract all your A's, okay, because your A1, A2, and A3 are all the same. You can actually extract all the A's, extract all the E's, okay, put it outside. The E is only one value because it's made out of steel, the whole thing. So you see 200, 200, 200. So in this case, I'm using everything in meter, okay, in meter. So the force is 20 kilonewton, so 20 times 10 power 3, length L1, 1 meter. Then the force at part 2, 15 kilonewton, and then the length is 2 meter. The force of part 3, 25 kilonewton, length 1 meter, all positive, okay? So put in everything, you will be able to find the total deformation on your own, okay, on your own, okay? You can redo all these questions, these 3 examples I've shown you, you can redo on your own. Please redo, okay? Don't leave it as it is, okay? You can always redo, okay, to practice. Thank you.